Hi all. Hi all. Welcome.
Hi, Professor. Hi, everyone.
Hi. Welcome. Hi,
How are you
Vate.
doing? How are you doing, Professor?
Pretty good. How you guys doing?
I'm doing good. I just want to hop in a little bit early today to ask you some questions as well. Um, I just want to know because I'm just gonna be here for a while just to figure out how things work here as well and see if it can help with anything in this class for now.
The only thing would be probably share the times that you're going to be available for them to contact you. That would be a good idea, I think. I'm planning to stay after the lecture for any questions that they might have. But basically, that's how am I going to conduct my lecture. I'm going to be writing the handouts and I'm going to be uploading the handouts for them on Canvas, and hopefully they're going to be able to download them and just follow the lecture that way.
Okay. So for most of the time, are you gonna lecturings for like 2 hours long with the 10 minutes break, or are you just gonna let them
No,
practice everything?
they're going to have a break, the normal break, the 10-minute break, and then we'll continue after the break.
Okay, okay.
Mm-hmm.
So I'm just gonna stay a little bit more to wait. Everyone is here, and I'm just gonna tell them my hours at MLC and how to access to it online as well, because right now everything is changed already. Yeah. And then I'm just gonna jump back to
but I also I think that you sent the information to me already on Canvas. I can share them. I can share the hours that you are going to be available, and you know, and from there also they have an extra help, you know, in case they need it.
Yeah.
All right, sounds good.
Yeah.
All right, so far we got 9. Very good. So just to let you know, we're going to be able to chat, you guys, and ask questions. Also, you can ask questions, you know, by using your computer or your cell phone alive. And let me know if anything, you know, anything that you guys are. Sometimes I might be off the webcam or something like that. You just let me know, you guys. Let me know, you know, and just to let you know that I'm happy to be here again and continue our course this way. And I believe that we're gonna be fine. We're gonna do okay, you guys. All right, so it is 1:30, and let's see if hopefully everybody has the handouts with you, and we're gonna start 4.1 polynomial functions and models. And I'm gonna start by reading the objectives. Identify polynomial functions and their degree. Graph polynomial functions using transformations, which we already know, transformations. Identify the real zeros of a polynomial function and analyze the graph of a polynomial function. All right, so let's start with the first objective. Identify polynomial functions and their degree. All right, so notice I have the definition All right, so let me check here. All right, so Vate and through chat something, and you guys can read it. The information which is going to be available for you guys. All right. Okay. Definition: a polynomial function in one variable is a function of the form f of x equals to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a1 times x plus a sub 0, where a sub n minus 1, a sub 0 are the coefficients. A sub n is the leading coefficient, and n is the degree of the polynomial. It says that the graph of a polynomial function is both smooth and continuous. All right, so let's talk about what is that. Smooth and continuous means that it has no gaps or openings, neither sharp turns. All right, okay. So when we analyze the first term of a polynomial, that first term tells us a lot of things about the polynomial as a whole. So those first term of a polynomial are known as power functions. All right, definition. A power function of degree n is a monomial function of the form f of x equals to a to the x to the n. Think of the power function as the first term of a polynomial, where a, which is a coefficient, is different from 0, and n is greater than 0. N is the degree, and is an integer. All right, I'm gonna turn the page right now. You notice, let's continue with the power function. On the left side, we have f of x equals to x to the n, and n is an even integer. Well, remember f of x equals to x squared, which is a parabola right there. So as you notice, it has an even integer. So the question is, what happens when that even integer increases? Let's say that now we have f of x, x to the 4th, or x to the 6th, or x to the 8th, all right? So what happens is that as n increases evenly, the increase, the slope of the, let's say the slope on the parabola now is going to be faster. It's going to increase faster. And I give you an idea how it's going to look. It's going to look similar to what I'm doing right here. In the bottom part, you guys, the bottom part is going to be flat. It's going to be similar to what I'm doing right now. So that's what the increase of the even exponent is going to look like. So let's say that this f of x is x to the 6th. All right. So there is, in the next section, we're going to cover a section that is known as end behavior, and I would like to cover that right now. And this is how it goes. Notice that here is increasing. Well, the end behavior, which I'm going to write it in red right here, the function f of x approaches infinity. That means that it goes to infinity as x approaches also infinity. As x goes to the right, f of x also increases infinity. I see probably a little bit of light here. I'm gonna close a little bit one of my windows here. All right, probably That helps. Yeah, looks better. Thank you. All right. So that is not the. This is the end behavior, by the way. End behavior. And if I go to the other side, right here, the end behavior right here, that is f of x approaches infinity as x approaches negative infinity. Let's see, that looks better right there. So again, f of x approaches infinity goes up as x approaches negative infinity, as x approaches negative infinity this way. That is the end behavior. All right. So that's where the power function, as we said, n is an even integer. Now, what happens now when n is an odd integer? Well, when n is an odd integer, a familiar function that we already know is the cubic function, which is x cubed right here, x cubed, okay? So, and the question is, what happens when this odd integer increases? Let's say now this is 5, this is 7, or this is 9. Well, kind of similar to the parabola. The graph increases faster. And also, let's say that we have this behavior right here. And at the base, flattens right here. Oh, excuse me. Excuse me, that was my phone. Let me turn it off. Sorry about that. All right. So this is what's going to happen. It's going to flatten right here. So here, let's say this is f of x equals to x to the 7th, right there. Okay. Now, what will be the end behavior for this kind of graphs right here? Well, for this kind of graphs, f of x goes to infinity as x approaches infinity. And here, the bottom part right here, the bottom part, the end behavior is f of x increases negative infinity. Because why negative infinity? Because it goes down as x approaches negative infinity. All right, so that would be the end behavior. All right. Again, if you have any questions, please feel free to ask or just go to the chat and I will check what you guys are asking. All right, so that's, let's continue here. Again, the power function is gonna let us a lot of things when we start graphing polynomials. Now let's continue. It says, identify the real zeros of a polynomial function and their multiplicity. We have this definition right here. If f is a function and r is a real number for which f of r is equals to 0, then r is called a real zero of f. All right, so let's talk about what are the real zeros. So for example, we know how to solve quadratic equations. When we solve quadratic equations and we find the values, those values are the x-intercepts. So those x-intercepts are the real zeros of quadratic functions. If we get those values and we evaluate the function at those values, the answer is going to be 0. So for any polynomial, if we solve it and we plug in the value in the polynomial and we get a 0, that means that those are the real zeros of the polynomial. So how do we find the real zeros of the polynomial? Well, let's give it a try. Let's try this exercise right here. It says, example, form a polynomial function whose real zeros in degree are given. The zeros are -1, 1, and 3, and the degree of the polynomial is 3. All right, so let me start by writing out the zeros. So one of the zeros is -1, that would be z equals to -1. The other one is z equals to 1. And the other one is z equals to 3. If I write these zeros as a factor, you guys, as a factor, this zero becomes, you know what, this should be x. Sorry about that. Can you change this to x? This should be x here. Let me change this to x right here. X. X equals to -1, x equals to 1, and x equals to 3. Again, if I want to write x equals to -1 as a factor, this would be x plus 1. X equals to 1 as a factor, that would be x minus 1. And x equals to 3 as a factor would be x minus 3. All right? So what is it that we're looking for? Well, we're looking a polynomial in this form, f of x equals to a times x plus 1 times x minus 1 times x minus 3. Notice that we have a, which is the leading coefficient. Here, we are going to choose a value for a. It could be any value, but to make our life a little bit easier, we can choose a equals to 1. So let me write it down. Make a equals to 1. And now that we know that a is equals to 1, all we got to do is multiply these binomials by using FOIL here. Notice. So if we do that, let me move right here, and I'm gonna do it. Well, let me finish right here. F of x equals to, what is x plus 1 times x minus 1? Well, notice that we're multiplying two conjugates here. And if you remember a formula, and let me write this formula for you. And I'm gonna do it right here. Remember this formula, a plus b times a minus b, that's equals to a squared minus b squared. I'm gonna use the formula to multiply x plus 1 times x minus 1. And if we use the formula, f of x now is equals to x squared minus 1 times x minus 3. Now, if we multiply x squared minus 1 times x minus 3, we're gonna FOIL those two. That would be x squared times x, which is x cubed. X squared times -3 would be -3x squared. -1 times x is negative x. Negative times negative is positive 3. And notice, that would be the answer. x cubed minus 3x squared minus x plus 3. Notice, that's the polynomial has degree 3, by the way. All right, so let me stop 1 minute right here for you in case you have you guys have any questions. All right, okay, seems that you guys don't have any questions. Let's continue here. So we're gonna try another exercise, okay? I'm gonna try another exercise similar to the one that we did, but before we try that, let me go over these two terms. One of them is even multiplicity. It says if x minus r to the m is a factor of a polynomial f, and m is an even greater than 0, m is the degree is even and greater than 0, then the graph of f touches the x-axis at r. So what is the meaning of that? It means that if we have a factor, these are factors, by the way, this is one factor and this is another factor right here. And if those factors have the degree even, that means that when we graph it at this value of r, the graph is only gonna touch the x-axis and it's gonna go back. That's an even multiplicity. So what about odd multiplicity? Odd multiplicity, if x minus r to the m is a factor of f and m is odd, greater than 0, then the graph of f crosses the x-axis at r. All right, notice, let's go back here. Here, this is a factor. Or we can go here also. All these three factors, by the way, all these three factors, the exponent is odd. This is odd multiplicity. That means that if we graph this polynomial, at these values at 1, at -1, 1, and 3, the graph crosses the x-axis at these 3 points. That's what it means. All right? So with this in mind, we're gonna try this exercise right here. Notice. We got zeros at -1, multiplicity 1, by the way. And we have another 0, which is 3, multiplicity 2. And what we're gonna get here is a polynomial of degree 3. So let me write the zeros the way I did it before. So we have 1, 0, 1, 0 at -1. But you notice the multiplicity is 1. So let me write it as a factor. As a factor is, oh, again, I'm going to use x here. Sorry about that. X equals to -1. As a factor, that would be x plus 1. Notice the multiplicity is 1. That means that it has a degree of 1 right here, which is odd, by the way. We also have another 0, which is 3. X is equals to 3. If I write this as a factor, that would be x minus 3. But notice that the multiplicity is 2. Well, that means that the degree is 2 right there. All right. So the degree is 2. That's the meaning of multiplicity 2. So if we were to graph this polynomial, since this is odd, the graph would cross the x-axis at -1. And this is even, the graph will touch or would touch the x-axis at 3, but it's gonna go back. It would not cross the x-axis, only would touch the x-axis at 3. So let's continue here. Again, we're gonna choose a to b equals to 1. And if that's the case, this is what we have. F of x is equals to x plus 1 times x minus 3 squared. But remember, we're not done yet. So we need to square this binomial. And then after we square this binomial, we're going to multiply it by x plus 1. So I'm going to give you a couple of minutes for you to try it. So let me give you a couple of minutes for you to try. I would start by squaring this binomial first, and then multiply that by x plus 1. So I'm gonna wait for a couple of minutes and give it a try. Let's see what we get. You can write the answer on the chat, or you can just say your answer aloud for everyone to hear. Remember that everybody's listening to me. And also, if you guys also, one of you like to speak, everybody's gonna listen to you. And at the same time, everybody's gonna see what one of you is gonna write on the chat. So give it a try, please. Give it a try. Let's see what we get. Again, if you guys got the answer, you want to share that with your classmates, feel free, okay? You can write it on the chat. You want to? That would be a good idea. All right, so let me catch up to you. Let's see what you guys doing, okay? So I'm gonna leave the x plus 1 the way it is, and I'm gonna square this binomial. Remember the shortcut, the square of the first minus 2 times the first times the second. 2 times 3 is 6 times x plus the square of the second plus 9. And then we're gonna use FOIL. We're gonna FOIL these two polynomials right here. So f of x equals to x times x squared is x cubed. X times negative 6x is negative 6x squared. X times 9 is 9x. All right. Now I'm going to continue with the 1. 1 times x squared is plus x squared. 1 times negative 6x is negative 6x. And 1 times 9 is 9. Now I'm going to combine like terms. F of x, well, seems that the x cubed stays by itself. What is negative 6x squared plus x squared? That would be negative 5x squared. What is 9x minus 6x? That is what? Positive 3x. And what is left is the 9 plus 9. All right. Okay, so I'm gonna check the chat here. And x cubed minus plus, very good, you guys. Really good, really good. Thank you, really good. Very good, nice. Thank you, Fletcher, Mary, thank you. Jill, very good. Okay, good question. What is it that it says degree 3? Well, that's what we're expecting, by the way. Good question, Mary. what it says here, multiplicity 1, 3, multiplicity 2, degree 3, that's what we expect to be the polynomial. The polynomial is going to be degree 3. This is what it means. That the polynomial that we're looking at the end is going to be degree 3. That refers to that number right here. So that's correct. That's degree 3. All right. So that's what it means. All right. Yes, Zoe, you're right. That's the higher power that we're going to be looking at the answer. Yes. So that's a good reference when you're done with your problem and look at the degree that you're expecting. And if that's the degree that you got, hey, very close to the right answer. Pretty good. All right. So pretty good, you guys. Right. Let's continue. All right. Turning points. So happens that when you have a polynomial and you know the degree of the polynomial, which is n, and if you were to graph, which we're going to be doing later on, graphing polynomial, and if we wanted to know how many turning points the polynomial is going to have, that would be n minus 1 turning points, by the way, n minus 1 turning points. If the degree is n, then f has at most n minus 1 turning points. Okay, so let me check really quick. All right, thank you, Vate, for joining us, and we'll keep in touch. Thank you. All right, so that was about the turning points. So let's try this exercise. It says, find the polynomial function with the given zeros whose graph passes through the given point now. Notice, they're not giving us the degree that we're expecting. They're giving us the zeros and also a point where the graph is going to pass, which these are the zeros and this is the point. All right, so let's try A together. Very similar approach as we did before. So for A, let's start with the zeros. X equals to -2. Again, as a factor, that would be x plus 2. The other one would be x equals to 0. As a factor, that would be only x. And x equals to 2. As a factor, that would be x minus 2. All right, those are the zeros that are given. But notice that also a point is given to us. How we're going to be using that point to get a polynomial that we're looking for? Well, remember, this is what we're looking for. F of x equals to a times, you can do it anyway here. X plus 2 times x minus 2. Alrighty? So notice that also f of x is the same as y, right? I'm gonna exchange f of x for y. I'm gonna tell you why right now. So if I write it this way, which is the same, and let me just change the order, okay? Ax times x plus 2 times x minus 2. So when you change the order to the right, it doesn't matter because we are multiplying. So the order doesn't matter, by the way. Notice, we need to find the value of a now. How we're gonna find the value of a? With the value of x and y. Notice, this value, the point that is given, this is x and this is y. Well, in order to find a, we're gonna substitute these two values instead of y and x, and we're gonna be able to solve for a. All right, so let's do it together. So notice this is x and this is y. So y is 16 equals to a times x. X happens to be -4. times negative 4 plus 2 times negative 4 minus 2. Everybody okay? We're substituting the values of y and x, all right? So let's do the math here. 16 is equals to a. Now we have negative 4 times, what is negative 2? Negative 4 plus 2? Well, negative 2. What is negative 4 minus 2? Negative 6. All right, let's see what we get on the right side. I have a times negative 4 times negative 2, that would be positive 8. Positive 8 times negative 6, that would be what? Negative 48, right? Okay, so, and a is equals to what? A is equals to negative 16 over 48. That 16 goes into 48. Seems that it goes 3 times, right? So A would be 1/3. Negative 1/3, by the way. A would be negative 1/3. All right. So now that I know what A is, let me continue right here. So now f of x is equals to negative 1/3 times x times x plus 2 times x minus 2. So let's FOIL all these factors here. Let's start with these two. Notice these are two conjugates. We're gonna apply the same formula as we applied before. And this is equals to f of x equals to negative 1/3 times x squared minus 4. Okay. All right, probably some of you already got the answer. They're pretty good. Let me check on that. Okay, let me check on that. Notice that here on the right side, I'm multiplying, right? I'm multiplying here. Everything is multiplying here. Negative 4 times negative 8, which is positive 8, times negative 6, that would be negative 48, right? The negative 48, you guys, by the way, don't get confused here. Here is, we are multiplying, by the way. We are multiplying. Probably if I write that parenthesis, that'll probably clarify your questions. We're multiplying. This is 8 times negative 48. So in order to solve for a, I have to divide by negative 48 on both sides. I just place the negative up here in front. It doesn't matter where I place it, but remember, we're multiplying negative 48 times a, and in order to solve for a, I have to divide by 48. And then a is equals to negative 1/3. Hopefully that clarifies your question. Good question, by the way. Good question. All right. Okay, perfect. So, yes. All right, pretty good. Pretty good. All right. Now, thank you, guys. Yes. So I think that parenthesis helps a lot to clarify that. All right, pretty good. All right, so it will continue here. Now what we have is f of x equals to negative 1/3. Now I'm gonna multiply here. I'm gonna distribute the x. That would be x cubed minus 4x. Okay, so let me do this here. The 1/3, you guys. Okay, is multiplying that. Okay. So the 1/3, then the 1/3, I had to multiply by x cubed minus 4x. So now I have f of x equals to negative 1/3 x cubed. Negative times negative becomes positive 4/3 x. And this should be the final answer. All right. All right, so let me see, you have any questions? All right, so let me give you a couple of minutes for you to try B. The zeros are -3, 1, and 4. So let's give it a try. Let me give you a couple of minutes for you to try B. Let's see what you guys get. Thank you guys for your participation. I really appreciate that. Again, if you guys want to share your answer, feel free. All right, let me catch up to you. Let's see what you guys have so far. So again, notice these 3 steps. You can write these 3 steps into one single step, like here, you guys, if you know what you guys doing. So it seems that some of you probably have already some answers going on here. Oh, okay. Yeah, the point is 6,180, by the way. Yes. Yes, definitely. It is at 6,180. All right. So if you guys want to write it in one single step, you know what you guys are doing. Similar to A, let me just start by writing f of x equals to A times x plus 3 times x minus 1 times x minus 4. So that would be the first step. Let me give you another minute for you to continue here. Now from there, we're going to find the value of A by substituting 6 and 180. So f of x is the same as y, right? Here, would you guys substitute 180, A. Now, the value of x is 6. That would be 6 plus 3 times 6 minus 1 times 6 minus 4. And now you have 180 equals to A times x, 6 plus 3 is 9 times 6 minus 1 is 5 times 6 minus 4 is 2. So 5 times 2 is 10, 10 times 9 is 90. So that would be 180 equals to A times 90. I'm using the parentheses now to avoid any confusions, you guys. And if we solve for A, you have to divide by 90. That would be 180 80 divided by 90, and A happens to be what? 2. A is equals to 2. I'm sorry. Yes, no, that is correct. A is equals to 2. All right, so now what we have is f of x equals to 2 times x plus 3 times x minus 1 times x minus 4. Remember that here we're not done. We need to FOIL all these binomials here. Start by foiling these two binomials. And let me do it this way. If I FOIL x plus 3 times x minus 1, that would be x squared. I'm sorry, that's x squared minus x plus 3x minus 3 times x minus 4. And this is equals to f of x equals to 2. I'm going to simplify here. That's x squared plus 2x minus 3 times x minus 4. Now I'm going to multiply all of this. That would be f of x equals to 2 times x squared times x. That would be x cubed. X squared times negative 4, negative 4x squared. 2x times x is plus 2x squared. 2x times negative 4 is negative 8x. Negative 3 times x is negative 3x. Negative times a negative becomes positive 12. Let me just recheck it. X squared times x is x cubed. X squared times negative 4 is negative 4x squared. 2x times x is 2x squared. 2x times negative 4 is negative 8x. Negative 3 times x is negative 3x, and plus 12. All right. All right. So the final answer now we have f of x equals to 2x cubed minus 8x squared plus 4x squared minus 16x. Oh, excuse me. Well, I could simplify here. Well, I'm going to simplify at the end, okay? Negative 6x plus 24, okay? All right, so f of x is equals to 2x cubed. And negative 8 plus 4, that would be negative 4x squared. Negative 6 minus 16, that would be negative 22x plus 24. All right, so let's see what you guys got. Pretty good, you guys. All right, Fletcher, pretty good. Very good job, you guys, very good. All right, please try it, finish the problem. Make sure that you guys are getting what we're getting here. Very good, very good. Right there, that looks better right there. All right. You ready? Okay, so let's move on. Let's continue here. Let me turn around here. We're gonna try these exercises here. And it says, for each polynomial function given I, f of x equals to 3 times x minus 7 times x plus 3 squared, A, list each real zero in its multiplicity. Okay. All right. So let's list the real zero. For x minus 7, let me start here. For x minus 7, the real zero is x equals to 7. What is the multiplicity? How do I know the multiplicity? Well, the multiplicity is this exponent here. This is multiplicity 1. So I will write it this way. Multiplicity 1. Okay. Now, for x plus 3 squared, the real zero is x equals to negative 3. The multiplicity is 2. All right, so that's what we're looking for. Again, if we were to graph this polynomial, that means that at x equals to 7, the graph would cross the x-axis. At x equals to negative 3, the graph will touch the x-axis at this point, but it would go back. It would not cross the x-axis. It only touches the x-axis at this point. All right? So let's try B. It says determine whether the graph crosses or touches the x-axis at each x-intercept. Well, I just said it. All right, so we can write it. We can write at x equals to 7, the graph crosses the x-axis at x equals to negative 3. The graph touches the x-axis. Already? All right. It says maximum number of turning points. In order to know the maximum number of turning points, we need to find the degree. We need to find n first, right? So what is n? Can we tell, let me go back to the polynomial f of x. Can we tell the way it's given the polynomial, what would be the value of n? All right, so let me just wait to see if any of you can figure the value of n. Well, let me just go here, let's see. Pretty good. Ian and Zoe, yes, it is 3, by the way. N is equals to 3. So let's see why. Why is 3? Because notice, this x, if you square this binomial, this x will be x squared. And here we have another x. So you multiply x times x squared, that will be x cubed. So n is equals to 3. That's how we find the value of n if the polynomial is given in this way. So n is equals to 3. Since n minus 1 is the number of turning points, so here 3 minus 1 is 2. Then 2 is the number of turning points. All right. All right. It says determine the end behavior. All right. In order to determine the end behavior, I need to know the degree. Notice n is equals to 3. By knowing the degree, I can tell the power function. I can tell the power function. So, oh, excuse me. Let me go back here. Already. Determine the end behavior. In order to determine the end behavior, let me find the power function of this polynomial right here. Notice. Since we know that the leading term is the degree is 3, the power function, okay, and probably some of you already got it. And I'm gonna write the power function, okay? Power function. The power function is f of x equals to 3x cubed. That would be the power function. From this x cubed, I can find the end behavior. If you guys go back to on the page, the second page, and we found the end behavior for the cubic function, that should be the end behavior for this polynomial, by the way. And some of you, okay, Fletcher is asking, why did you subtract 1 from 3 for the turning points? Because because of the turning point theorem. Thank you, Mary. Yes, yes, very good. Yeah, you go back, Fletcher, and you read the theorem. It tells you how do we find the number of turning points. All right, pretty good. Okay, if we continue here with the power function, they tell us this number tells us the end behavior. So if you go back to the end behavior of the cubic function, that should be exactly the end behavior for this polynomial. So let me write the end behavior. So the end behavior is as f of x approaches infinity, as x approaches infinity, and f of x approaches negative infinity as x approaches negative infinity. That would be the end behavior, by the way. This is the end behavior. All right, again, this degree, this power tells us the end behavior. This is the leading term, the power function. All right. All right, so let me stop here for 1 sec. Notice we have another exercise, which I'm gonna let you for you to try later on, okay, on your own. I don't think that is difficult, by the way. And if you guys don't have any question at this point, let's take a break. Let's take a 10-minute break. We'll continue at 2:35, 2:35. All right, so let's take a break. Let's get a glass of water. ask a big favor? Ask a big favor. Any feedback that you guys can tell me what to do differently if this is working for you? I really appreciate it. Remember, this is our first time meeting in this format. And my goal is to make it better every single time that we meet. So your feedback is always appreciated. All right, so we're gonna start 4.2. I also uploaded 4.2, but probably was under a different like 5.6. Can you change that to 4.2, please? This the section number to 5.2, please. This should be 5.2. I'm sorry, that would be 4.2. I think that for you guys is 5.6. And the title of 5.2 is the real zeros of a polynomial function, the real zeros of a polynomial function. So we know what a real zero is already. So we just found out in 4.1. All right, so let's read the objectives. It says, use the rational zeros theorem to list the potential rational zeros of a polynomial function. Find the real zeros of a polynomial function and solve polynomial equations. Solve polynomial equations. All right. So let's read this theorem, the factor theorem. Suppose f is a polynomial function, then x minus c is a factor of f of x if and only if f of c is equals to 0. We noticed before when we were writing in 4.1 the polynomials, and this is a factor. And if you evaluate a polynomial at the value of c, which before in 4.1 we were calling this r, by the way, and this is equals to 0, then this is a factor of a polynomial. All right. So let's try this exercise. It says, example, use the factor theorem to determine whether the function f of x equals to 2x cubed minus x squared plus 2x minus 3 has the factor x minus 1. All right, how can we find if this one is a factor of f of x? There is more than one way. There is at least 3 different ways. You can plug in this one instead of the x in f of x, and this happens to be 0, then this one is a factor. Another way would be using long division, and another way is to use synthetic division. Since we're mostly be using synthetic division here, and probably some of you remember how to do synthetic division. If you guys don't remember, some of you don't remember, we'll remember right now. So we're gonna use synthetic division, okay? So this is known as synthetic division. And this is how you guys set it up. Here we're gonna write the coefficients of the polynomial. We're gonna write the 2, the -1, the 2, and the -3. 2, -1, 2, -1, positive 2, and -3. And here goes the value of c, this value of c right here. Notice that x minus z, here we have x minus 1. What is the value of c? Well, the value of c is 1, so the 1 goes right here. This is the setup. Now we're going to start this synthetic division. First thing that we're going to do is we're going to bring down the 2. We're going to bring down the 2. The 2 goes here. And then we're going to start multiplying what is 1 times 2. And we're going to write the 2 right here. And now we're going to add these two numbers, -1 plus 2, +1. And we're going to repeat the process. 1 times 1 is 1. You write it here. 2 plus 1 is 3. 1 times 3 is 3. -3 plus 3 is 0. Notice this 0 is the remainder, by the way. This is the remainder. If the remainder is equal to 0, that means that x minus 1 is a factor of this polynomial. So we can use synthetic division to factor polynomials, doing it this way. So I can write the answer as x minus 1 is a factor of f of x. So let's try it. Let's try another one here. Let's say that now b is equals to x plus 2. X plus 2. And I want to find out if x plus 2 is a factor of f of x. So we're going to use synthetic division the same way as we did before. But now I have x plus 2. The question is, what would be the value of c now? So let me write the same 2, -1, 2, and -3. So what would be the value that goes here now? What would be the value of c here? So let me give you one minute for you, or a couple of seconds for you to tell me what would be the value of c. What is the value that goes out there? Okay, let's see. That would be -2. You're right. Yeah, pleasure. That would be -2. Why is that? Okay. So notice the format has to be x minus c, but here we have x plus 2, right? So if we rewrite x plus 2 as x minus -2, notice that this format looks similar to x minus c. Now c is equals to -2. So now the -2 goes right here. I'm going to let you finish this problem. First thing that you do is bring down the 2, and let me give you a couple of minutes for you to finish this problem. Let's see what would be the remainder. Again, if the remainder is equal to 0, then x plus 2 is a factor. If not is equal to 0, then it's not a factor. All right. So let me give you a couple of minutes for you to finish this problem. All right. So again, remember the steps. -2 times 2 is -4. You write the -4 right here. Then you add these two numbers. -1 minus 4 is -5. -2 times -5 is +10. 2 plus 10 is 12. -2 times 12 is -24. -3 plus -24 is -27. So conclusion is that x plus 2 is not a factor of the polynomial f of x. Why is not? Because we don't have a 0 right here. So let me write the answer. X plus 2 is not a factor of f of x. All right. Okay, so we're gonna keep practicing synthetic division. So we're gonna get really good at synthetic division. Here we have a theorem, number of real zeros, number of real zeros. It says a polynomial function cannot have more real zeros than its degree. A polynomial function cannot have more real zeros than its degree. The most real zeros that it might have is its degree, no more than that. That's what it means. All right, so let me turn this. All right, so that would be next right here. Okay. Here we have another theorem here, the rational zeros theorem. It says, let f be a polynomial function of degree 1 or higher of the form f of x equals to an to the x plus an minus 1 x to the n minus 1 plus a1x plus a sub 0, where a sub n is different from 0 and a sub 0 is different also from 0. It says where the coefficients, change these to the, where the coefficients, where the coefficients are integers. It says if p over q in lowest terms is a rational zero of f, then p must be a factor of a sub 0. What is a sub 0? The constant. And q must be a factor of a sub n. What is a sub n? The leading term. It says, how do we get the potential rational zero? Notice these are not the real zero. This is the potential rational zeros. The potential rational zeros are going to be found by using p over q, which are the factors of the constant a sub 0 over the factors of the leading term a sub n. Okay. All right, let's see. Okay, Ian, you never heard of synthetic division? Well, it is similar to long division, by the way, and it is easier than long division, but the only requirement is that in order to use synthetic division, the binomial has to be in the form x minus c, by the way. Okay, good. So this is how we're going to find the potential rational zeros, you guys, by dividing the factors of the constant divided by the factors of the leading coefficient, which is a sub n. All right. So let's try an exercise. It says, finding the real zeros of a polynomial function. Finding the real zeros of a polynomial function. Example. It says, find all real zeros of each polynomial function. Use the zeros to factor f over the real numbers. And f of x is equals to x cubed plus 2x squared minus 5x minus 6. So we're going to factor this polynomial. So first thing that we're going to do is we're going to find the potential rational zeros. In order to find the real zeros, we're going to find the potential rational zeros first by finding the factors of the constant divided by the factors of the leading coefficient. So let's give it a try. So let me write it here. Potential rational zeros. So that would be the factors of the constant. Here the constant is -6. What are the factors of -6? Well, that would be plus minus 1, plus minus 6, and also 2 and 3, right? Comma, plus minus 2, comma, plus minus 3. Those are the factors of -6, the constant. Notice it is divided by the factors of the leading coefficient, which is a sub n. Excuse me, the leading coefficient here is 1. We don't write the 1, but it's implied right here, right? So that will be divided by plus minus 1. Notice it's a division. So what are the potential rational zeros? Well, plus minus 1 divided by plus minus 1, that's equals to plus minus 1. Plus minus 2 divided by plus minus 1, that will be plus minus 2. Plus minus 3 divided by plus minus 1, that will be plus minus 3. And plus minus 6 divided by plus minus 1, that will be plus minus 6. These are the potential rational zeros. What is the meaning of the potential rational zeros? That among all these potential rational zeros, we're going to find the real zeros in order to factor this polynomial. After we have the potential rational zeros, we're going to start using synthetic division to find the real zeros. So remember that in order to find the real zeros using synthetic division, the remainder should be 0. So let's give it a try. So again, you can start in any order that you want. I usually start with plus 1, then -1, plus 2, and -2, okay? So I kind of follow that order, okay? Okay, it says, Jill, is that supposed to be plus minus 3 or plus minus 5? Well, notice plus minus 5 is not a factor of -6. Okay. It is plus minus 3. Okay. It is plus minus 3 plus minus 1 because why is that? Notice why we're using the plus minus, because positive 1 times positive 6 is 6. -1 times -6 is also positive 6. So that's why we're using the plus minus, you guys, okay? You might be a little bit confused here because we usually use most of the time the positive numbers, okay? But the negative numbers also should be included, by the way, okay? So what will be the next step? Well, the next step, we're going to use a synthetic division to find the real zeros. Find the real zeros. All right. Again, same steps as before. Get the coefficients of the polynomial, which is 1, 2, -5. This is the -5 and -6. And then I'm going to start with positive 1 here. Okay. And let's see what I get. Bring down the 1. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. -5 plus 3 is -2. 1 times -2 is -2. -6 minus 2 is -8. -8. Notice that I have -8 here. So far, 1 is not a real zero. So let's try -1. Let's see what we get. Let's try -1. Okay. All right. Okay. Pretty good for your feedback, you guys. So let's try negative 1 here. Now let's try -1. 1, 2, -6, -5, -6. Now let's try the -1 here. Let's see what we get. -1 times 1 is -1. 2 minus 1 is 1. -1 times 1 is -1. -5 minus 1 is -6. -1 times -6 is positive 6. -6 plus 6, notice we got a 0 here. So that means that -1 is a real zero of f of x, okay? So let me write it right here. Well, let me do 2 steps here. I'm gonna write, since -1 is a real zero here, I know that x equals to -1 is a real zero, but notice what is left, 1, 1, and -1. I'm gonna rewrite what is left here, these coefficients, as polynomials. So we'll start with this 1. When we write a polynomial out of these coefficients, the polynomial that we're gonna write here is one less degree of the original polynomial. Notice here was x cubed. This polynomial is gonna start with x squared. So here, this is translated to x squared plus x minus 6. All right? So we said that -1 was a real zero. So I can write this as x equals to -1. And if I write this as a factor, that would be x plus 1. Okay? So now if I put it together, you guys, f of x is equals to x plus 1 times x squared plus x minus 6. Let me stop right there. Where did I get x squared plus x minus 6? That's the polynomial that was left here. Okay? All right, so let me see. All right. Okay, perfect, you guys. Thank you for clarifying with the chat to each other. Thank you. I can see that. All right. So let me go back here. Is that clear so far how we got these two factors, right? So the x plus 1 again comes because -1 is a factor here, and this x squared plus x minus 6 comes from this polynomial right here, right? Here, you guys, we can proceed here like using a synthetic division here and finding more real zeros this way. But notice, I decided to write it this way. Why? Because remember that we're looking for the real zeros, right? So let's see if we can factor this trinomial here. Can we factor x squared plus x minus 6 using big X? So let's give it a try. -6 and 1. Seems that probably the +3 and -2 is going to work. That works. Everybody notice that? Yes, perfect. Very nice. Very nice, Ian. Very nice. So let's put it together now. Now f of x is equals to x plus 1 times x minus 2 times x plus 3. Remember that we're finding the real zeros. So to find the real zeros, let's make f of x equals to 0 and solve for x. Real zeros, let's make f of x equals to 0 and solve. So that would be x plus 1 times x minus 2 times x plus 3 equals to 0. So here we have x plus 1 equals to 0, or x minus 2 equals to 0, or x plus 3 equals to 0. And now the solutions are x equals to -1, or x equals to 2, or x equals to -3. Okay. So that would be the solution. Just thinking about my math lab, how will my math lab would like the answers. Just read the indications. Probably would be -1, comma 2, comma -3, something like that, you guys. So probably it would tell you how to write the solution. But let me know if you guys have any questions at all. So this is how we find the real zeros. All right, notice we're using synthetic division here. All right, so let's continue here. All right, so let me give you a couple of minutes for you to try B. Again, we want to find the real zeros of the polynomial f of x. All right, so let me give you a couple of minutes for you to try. So same steps as before. First thing that we're going to do is find the potential rational zeros. List the potential rational zeros, and after that, start using synthetic division to find the real zeros. All right, so let me give you a couple of minutes. All right, so what would be the potential rational zeros? Potential rational zeros. What are the factors of -1, plus -1? What are the factors of the leading coefficient? Plus -1, comma plus -2. Now let's find the potential rational zeros. What is plus -1 divided by plus -1? That would be plus -1. What is plus -1 divided by plus -2? That would be plus -1/2. All right, so those are the potential rational zeros. So now let's start using synthetic division. Okay, Jill, how do we get the plus -1 from the numerator? Because notice that in order to find the potential rational zeros is the factors of the a sub 0, which is the constant, which is -1. What are the factors of -1 plus -1? Remember, are the factors of the constant divided by the factors of the leading coefficient. Okay, that's how we got the plus -1 from this -1. Okay, and let me see, you have another question here. All right, perfect. Okay, so now start your synthetic division, and it's up to you. You want to start with plus -1/2 or plus -1, it's up to you. All right, so let me give you a couple of minutes for you to try, because I really want you to practice synthetic division, because this is how we're gonna find the real zeros. Okay, so let me give you a couple of minutes for you to try. Just to let you know, after we're done, I'm gonna pause this video and I'm gonna send a link to you. You guys wanna go over in case you guys have any questions or any doubts. You can go over and watch the video again, and from there see what we did. All right, let's see. Let me try to catch up. All right, so what are the coefficient is 2, -1, 2, and -1. So by the way, make sure that when you look at the polynomial, all the corresponding degrees are present. See, here we got 3, 2, 1, and 0. What if 1 degree is missing? If 1 degree is missing, let's say if x squared is missing, use 0 as a placeholder. If x squared was missing here, instead of writing the -1, I will write the 0 right here, okay? All right, so let's start with 1. Let's see, 1 is a real 0. Bring down the 2. 1 times 2 is 2. -1 plus 2 is 1. -1 plus 2 is 1. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. -1 plus 3 is 2. Notice +1 is not a real 0. All right, so let's try -1. Let's try -1. 2, -1, 2, -1, -1. Bring down the 2. -1 times 2 is -2. -1 plus -2 is -3. -1 times -3 is +3. 2 plus 3 is 5. -1 times 5 is -5. -5 minus -1 minus 5 is -6. So neither 1 or -1 is a real 0 so far. Let me see how you guys doing here. Okay, Jill got 1/2. Mary got 1/2. Okay, let's try 1/2. Okay, all right, so let's try 1/2. 1/2, +1/2. That would be 2, -1, 2, -1. So let's bring down the 2. -1/2 times 2 is 1. -1 plus 1 is 0. 1/2 times 0 is 0. 0 plus 2 is 2. 1/2 times 2 is 1. -1 plus 1 is 0. So 1/2 is a real 0, by the way. Okay. Okay, we're gonna do the same as we did before, you guys. We're gonna do the same as we did before. So x equals to 1/2, right? Okay, I'll check your chat right now, okay? X equals to 1/2. This is a real 0, right? As a factor, that would be x minus 1/2, right? And notice what is left here in the remainders right here, the 2, 0, and 2. If we rewrite these values, these coefficients as a polynomial, remember these 2 would be with x squared. Remember this degree of this coefficient should be 1 less than the original degree of the polynomial. So now this would be x squared plus 2, all right? And now I'm gonna have f of x is equals to x minus 1/2 times x squared plus 2. I'm gonna check your chat, you guys. Some of you already found already the answer, which is, all right. Okay. All right. So let me all right. Okay. All right. So let's see. Let's see. Ready? I like your participation. Really good, you guys. Let's see. Let's check on the answer. Okay. So remember that we're finding the real zeros, right? So if we find the real zero, let's make f of x equals to 0 and solve, right? And solve. So that would be x minus 1/2 times x squared plus 2 equals to 0. And now we have x minus 1/2 equals to 0, or x squared plus 2 equals to 0. Alrighty? So all right, so let's check on that, okay? Because what did we solve for x here for the first one? So if we solve for x here, we have x equals to 1/2, right? Or now I'm gonna answer Ian's question right here, okay? So how do we solve x squared? Let me get rid of the chat right here, you guys. How do we solve x squared plus 2 equals to 0 here? So we're gonna use the square root property here. So this is the same as x squared equals to -2, right? And then using the square root property, if x equals to plus minus, you guys, is square root of -2. X equals to plus minus square root of -2. Now, what is the square root of -2? Well, that is an imaginary number, you guys. That's an imaginary number. So this is equals to x equals to plus minus a square root of 2i. So we have x equals to 1/2 and two imaginary solutions here. Let me see right here. Oh, yeah, you're right. So you know what? It should be here. Thank you. Thank you, Zoe. Thank you. This should be, since this should be 2x squared plus 2, by the way. This should be 2x squared plus 2. Thank you. Thank you very much. So let me make the correction right here. 2x squared plus 2. 2x squared plus 2. All right? So let me solve it right here on the right side, right here. Let me get rid of this. Yes, I was missing the 2. All right. So here, if I continue here, 2x squared equals to -2, and x squared equals to -1, right? Now, using the square root property, that would be x equals to plus minus a square root of -1, and x equals to plus minus I. Okay, that would be the correct answer, you guys. Thank you. Thank you. I was missing that too. This should be the correct answer. X equals to 1/2 and x equals to plus minus I. That is the right answer. Well, I really appreciate that. Thank you, Zoe, and thank you all of you that noticed that. All right, pretty good. Thank you, guys. Very good. So those would be the solutions for that, okay? Perfect. All right, very good. Okay, so let's try one more. Notice here, these are the potential rational zeros. And let's do one more exercise. Let's try it on solve. We're solving this equation right here. Well, same steps as we did before. It's the same as we're gonna find the real zeros, but now this is equals to 0. Now we're gonna be solving. So first thing that we're gonna do, and I'm gonna give you a couple of minutes for you. First, find again the potential rational zeros. The potential rational zeros, and from there, let's use the same process as we did before. Let's use Interrogate Division to find the values of x. That's what we're gonna find. Okay. So let me give you a couple of minutes for you to start this problem. And hopefully all of us were getting a good practice of Interrogate Division. Again, this is wrong. Okay, just because I'm recording this, so that is wrong. Just all right. We got like 3 or 4 minutes left. Okay, so what are the potential rational zeros? Potential. So that would be, what are the factors of -8? Well, plus minus 1, plus minus 2, plus minus 4, and plus minus 8, right? And divided by the factors of the leading coefficient, which is plus minus 1. So the potential rational zeros are going to be plus minus 1, comma, plus minus 2, comma, plus minus 4, and plus minus 8, right? And from here we start using the synthetic division to find the solutions. All right. So I'm gonna let you you guys finish this problem. Okay. But I want your feedback, you guys. I want to know if how we're doing. If you like this format, the way we are proceeding right now today, and if you're suggesting any changes at all. Again, this is our first day. Hopefully it went well. And again, I'm gonna create a video of this session, and I'm gonna upload it. I'm gonna stay here a couple of minutes after this lecture to see if any of you have any questions, any concerns, right? So thank you for correcting your exams and email it back to me. So remember that from now on, the exams are going to be online. Most likely, I'm going to give you like 2 days to solve the exam and return it. But corrections are not allowed anymore. Okay, so So Ian, since that found already the answer, I wonder, Ian, are these the answers that you found? -1, 2, 4, and 8? Or, oh, plus or minus. Yeah. So those I believe this, Ian, these are the potential zeros. Thank you, Ian. Thank you for clarifying that. So from here, you guys, start using the Interrogate Division to find the real zeros, and then you follow the same steps as before to find the to solve these equations, find the values of x. All right. So again, you guys, I really appreciate it. You guys give me your feedback. Tell me if anything has to be changed, or you think that's okay how we did it today. Okay. Zoe got a 2 as an answer. Okay, pretty good. So okay, good question. How once you got the first 0, how do you keep going? Okay, after you find 2, let's say that you guys found 2, whatever that you have left, you know what? Let me show you what to do here. Okay, but basically, let's say that you guys found the 2 as a real 0 here. Let me see, 1, -1, 2, -4, -8, and here you got the 2. So this is 1, 2 times 1 is 2, -1 plus 2 is 1, 2 times 1 is 2, 2 plus 2 is 4, 2 times 4 is 8, -4 plus 8 is 4, 2 times 4 is 8, and this is 0, okay? So you got this, and you're left with this. If you rewrite this coefficient as a polynomial, this is what you guys have left right now, okay? X cubed plus x squared plus 4x plus 4, right? This is what you guys have left. Okay. Now, continue using synthetic division now with these coefficients. So this would be next. Write the coefficients here, 1, 1, 4, and 4. Again, you stop at +2 or -2 and continue from here. You can also go back and start with positive ±1 again here, okay? That would be the sequence. Start with ±1 here, or you can continue with the ±2 here, or with these values here, and you're gonna get the other zeros that you need here. Is that clear, you guys? And after you get the other 0 here, I don't know if you guys, let's see. What if you try -2 here? Let's see if you guys try -2 right here, really quick. 1, -2 times 1 is -2. 1 times -1 plus -2 is -1. Negative times is +2 here. That is 6. This is -12. Well, this is not 0, by the way. Okay, so -2 is not. But what if I try the 4 here now? One, 1, 4, and 4. Bring down the 1 here. 4 times 1 is 4. 1 plus 4 is 5. 4 times is 20, 24. 4 times 24 is a big number. That's 6. And that's 8, 9, 96. So that would be 100. So the 4 is not a 0 here. Okay. So let me continue here. What about -4? Is it -4? We do a -4 here. That would be 1, 1, 4, and 4. -4 times 1 is -4. 1 times -4 is -3. Negative times negative becomes positive. Positive 12. That would be 16. -4 times -4 times 16. Well, this is not a 0. So -4 is not either, right? So let me continue with positive 8. 1, 1, 4, and 4. Again, I might have to come back to plus minus 1, okay, you guys? 1 times 8 is 8. 1 plus 1 plus 8 is 9. 8 times 9 is 72. This is 76. 8 times 76 is a big number right here, so it's not going to be 0. Let me try -8 now. 1, 1, 4, and 4. Here is 1. Negative 1, negative 8 times 1 is -8. 1 times -8 is -7. 8 times 7 is 56. So notice that -8 and 8 doesn't work. I might have to go back to plus minus 1 here. So let's see. 1, 1, 4, and 4. What if I have the 1 here? 1 times 1 is 1. Okay. So 1 plus 1 is 2. 1 times 2 is 2. That is 6. So the plus 1 is neither. Try the -1. 1, 1, 4, and 4. -1. -1 times 1 is -1. This is 0. We have 0 here. The 4 here. -1 times 4 is -4. And this is 0. Notice the -1 again is another 0 here. So let's see what we have so far. Notice. This is what we have so far, you guys. We have x equals to 2, which as a factor is x minus 2. And also we have x equals to -1 as a factor is equals to x plus 1. But notice what we have left here as a polynomial here, you guys. If I write this as a polynomial, since this is x cubed, this should be x squared. So here I have x squared plus 4. And if I put it together, now I have f of x equals to x minus 2 times x plus 1 times x squared plus 4. Okay. And from here, we can find the answers, by the way. We can find the answer. Let me write the answer. Probably some of you already found them, okay? So from here, the answers are, well, I know that x squared, x equals to 2, or x equals to -1, or x squared plus 4 equals to 0. And let me solve here. X squared is equals to -4. And x is equals to plus minus a square root of -4. And that will be x equals to plus minus 2i. Notice, these are the solutions, you guys. These are the solutions. All right, so notice this is the process again. So let me go to the chat. Yes, Ian, you're right. Pretty good. -1 and 2, yes, perfect. Gil, thank you. So notice these are the steps. Already? All right, thank you, you guys, for participating. I really, really appreciate here. If you guys can give me your feedback, how to do this better, if you like this format, I mean, any changes that we can make to better these lectures would be appreciated, you know. And I'm gonna stay here a couple of minutes more for you in case you have any questions, you know. Dakota, thank you. You're welcome. Thank you, you guys. Thank you very much. I really appreciate you being here and your participation, okay? All right, so I'm gonna be assigning homework for these 2 sessions, okay? So I'm gonna stay here for a couple of minutes for you guys to ask questions. And if you don't have any questions, I mean, have a good day. We'll meet on Wednesday, same time. Okay. Alrighty. So, and this is it for today, you guys. This is 4.1 and 4.2. We finished both of them today. So again, as I said, I'm gonna assign homework, and then you guys can practice a little bit more. All right, so seems that you guys have no questions, but hey, thank you for your participation, and thank you for sharing your times where you're gonna be helping. I really appreciate that. Yeah, my math lab has some issues this weekend, you guys, by the way. That's why none of you could access the homework through my math lab. They were given maintenance to their website. Okay, that was the reason. But definitely, I'm gonna be opening the homework for you guys. Already? But hey, I think that was really good the way you were participating. Yes, I mean, yeah, perfect. But yeah, you're welcome to ask questions and to give them an idea of what they're doing. You know, yeah, perfect. That works for me. Perfect. Very good. I like what you're doing, but hey, pretty good. Thank you. Ian, don't worry. Yes, I would open it, Ian, and everybody else. I would open it right now. And for you guys are behind, you can catch up. Yeah, Bate, thank you, Jason, thank you, Ian, thank you, and everybody, thank you. Have a nice day, and I see you on Wednesday again, definitely. Take care, you guys, and keep safe, and be healthy. All right, I'm gonna finish